Today we're going to be looking at direct variation. So a direct variation will be in the form of y equals k times x, where k represents our constant. So in a direct variation, you multiply your constant by your independent variable. So the graph of every direct variation has to go through the origin. And their origin, remember, is at 0, 0. So when you graph it, if it does not go through 0, 0, it's not a direct variation, or you made a mistake somewhere. So let's take a look. Your distance from lightning varies directly with the time it takes you to hear thunder. If you hear thunder 10 seconds after you see lightning, you are about 2 miles from the lightning. So we're actually going to use this down here, that's saying that distance is a direct variation. So we use d equals r times t. So we're using our direct variation equation, just using different variables, where r is the constant instead of k. So here, if I use my direct variation equation, I know the distance it took was 2 miles. I don't know my rate, but I do know the time was 10 seconds. So to find my rate, if I divide both sides by 10, my rate is now 0.2. So my constant is 0.2. So my direct variation equation would be d equals 0.2 times by t. So let's take a look here. I'm still using distance equals rate times time. So I am needing to find the car's rate, and I want to write the function for the distance. So I'm using distance equals rate times time again. My distance was 102 miles. I don't know my rate, but I do know it took 1.5 hours. So in order to find my rate, if we divide both sides by 1.5, I'm finding that my rate is 68 miles per hour, so that's how fast it is going. So in using the distance formula, distance equals rate times time, if I take 68 and I multiply it by my time, I will be able to find how many miles the car has gone. Remember, in this case though, our time is in hours. So if I find the distance, I want to find the distance the car traveled in 4 hours. So I don't know what my distance is. My rate is 68, and I'm traveling 4 hours. So 68 times 4 means that I have traveled 272 miles. So now we want to take a look at our table, and we want to determine whether y varies directly with x, and if it does, we want to write a direct variation. So if it's going to vary directly, if I'm looking at all of these examples, I was actually taking my x values and using that to divide by my y's. So if I take 2.4 and I divide by 2, I end up with 1.2. If I take 6 and divide by 5, that equals 1.2. And if I take 9.6 and divide by 8, I also get 1.2. So these are all constant. So that means this is a direct variation. So my equation is going to be y equals my constant times by my x. So here, if I take a look again, if I take my 5 and divide by 1, that equals 5. 11 divided by 5 is 2.2. So those are not constants. So this is not a direct variation. Here I want to write an equation for direct variation that the graph would go through this point. So if I have that my x is 6 and my y is 2, so remember I'm using my direct variation. So there's my equation. My y is 2. Don't know the constant, but my x is 6. So if I divide both sides by 6, k equals 0.3 repeating. So since we're dealing with a repeating number, change that into a fraction, which is 1/3. So now we know our constant is 1/3. So that means my equation is y equals 1/3 times by x. So let's try this one more time. My x is -2, my y is -10. So again, using my direct variation equation, y is negative 10, my x is negative 2. So if I divide both sides, my constant is a 5. So when I write my equation, it's y equals 5 times x. So the ordered pairs in each exercise are for the same direct variation. Find each missing value. So both of these are for the same direct variation equation. So I'm looking at my x and y. So again, we are still using y equals k times x because it's direct variation. So if I take my y, which is 5, and my x, which is k, and if I divide both sides by 2, I'm finding that my constant is 2.5. So since these are the same direct variation, that means my constant for this one is also going to be 2.5. So if I'm going to start over, I do know my y, which is 12.5. I know my constant is now 2.5, but I don't know my x. So in order to find x, I would divide both sides by 2.5. So that means x equals 5. So let's try this one again. So I have my x and my y. Again, I'm using my direct variation equation. So 5 equals my k times by negative 2. Divide both sides by negative 2. K equals negative 2.5. So there's my constant for both of my coordinates. So if I take my direct variation equation, I don't know my y. My constant is negative 2.5 and my x is a 2. So negative 2.5 times by 2 is a negative 5. So there's my y value. So now I'm going to look at graphing my direct variations. So if we remember from the front side that every graph of a direct variation has to go through the origin. So that means for my first graph, I have a point that has to go through my origin. So from here, I need to look at my constant. My constant in front of my x is a 1. So that is my slope. So if my slope equals 1, which is what my constant was, that means I'm going to rise up 1 and I'm going to go to the right 1. So up 1 to the right 1. And just to make sure I'm a little bit more accurate, I'm going to continue making those lines and then I'm going to connect. So there's my direct variation for that equation. So for next one, we start at 0, 0. My constant is a 3. So that means my slope is 3, which tells me to go up 3 to the right 1. So up 3 to the right 1. And I'm going to go in the reverse order. So here is my direct variation graph. These next two are even a little bit easier. We still are going to go through 0, 0, but it's also telling me I'm going to go through the point 1, 4. And I'm done. This one, it's a direct variation, so I'm going to go through 0, 0. And I'm also going to go through negative 1, positive 5. So there's my direct variation graph for that fourth problem.